Hey, quick question for you. What's the single most important piece of software on your computer? I mean, you use it every single second, but you probably never ever think about it. Well, today, we're going to pull back the curtain and meet the real unsung hero of your digital life. So, seriously, what do you think it is? Your web browser? That game you can't put down? Maybe that super powerful video editing software you use? Look, all of those are really important, for sure, but none of them could even run without the true hero of the machine. And the answer is the operating system, or OS for short. You got to think of it as the foundation of your computer. It's like the master conductor of a giant digital orchestra. It's the one program that is always running, making it possible for you to actually talk to the hardware and for all your other apps to do their thing.
So here's our game plan for this explainer. We're going to peel back the layers one by one. We'll start with how you interact with it, then we'll look at its main jobs, we'll meet its most critical component, the kernel, then we'll get into the crucial divide that keeps your computer from crashing all the time, and finally, we'll see why it's the absolute foundation of everything you do on your tech.
Okay, first up, how do we even talk to this thing? I mean, how do we give it commands? Well, the OS provides the portal, right? The interface that lets us tell the computer what to do and see what it's doing. It's the part we actually see and touch every single day. And we mostly do this in two ways. Most of us, we use a GUI, a graphical user interface. You know, the world of icons, windows, and your trusty mouse pointer. It's visual, it's intuitive. But then there's the CLI, the command line interface. This is that text-based world for developers and system admins. And here's the really cool part. Even though they look totally different, they're both just different doors leading into the exact same powerful room that is the operating system. All right, so beyond just showing us pretty icons, what is the OS actually doing? Well, it's constantly juggling a whole set of critical tasks. You can almost think of it like a government managing a really complex city, making sure all the resources are shared and that everything runs smoothly and fairly. And it all boils down to five core functions, five massive responsibilities that the OS is handling every single second your computer is turned on, totally behind the scenes. First up, process management. See, every single app you run is what's called a process. The OS is the scheduler, the boss, deciding which process gets to use the computer's brain, the CPU, and for how long. Now, why does this matter? Well, this is the magic that lets you listen to music while you browse the web and download a file all at the same time. That's multitasking, and it's all thanks to the OS. Next, we've got memory management. The OS is like the treasury department for your computer's RAM. It gives each application its own little chunk of memory, and, this is crucial, it protects that space. It builds walls around it. This is exactly why opening 100 browser tabs usually doesn't crash that video game you have running in the background. Each program has to stay in its own lane. Then there's file system management. This is basically the national archives for your computer. The OS creates that whole system of folders and files you know and love. It keeps a map of exactly where every little piece of data is on your hard drive. So when you double-click a document, boom, it opens instantly. Number 4 is device management. The OS is the universal translator for all your hardware. It uses these special little programs called drivers to talk to your keyboard, your mouse, your printer, you name it. This is the reason you can plug in a brand new mouse and it just works. The OS handles the introductions. And finally, protection and security. The OS is your system's own secret service. It enforces all the rules, making sure one user can't snoop on another user's files and that some random app can't just take over the whole machine. It's the bouncer at the door, protecting your data and the whole system. Now, let's go a layer deeper. If the OS is the government, then right at the very center, inside the most protected building of all, is the kernel. This isn't just part of the OS, it is the absolute, undeniable beating heart of it. And this quote just nails it. The kernel is the one and only piece of software that gets a direct all-access pass to the physical hardware. Everything else, every single application, every command has to go through the kernel first. It's the ultimate bridge, the ultimate gatekeeper. So how does that even work? It happens through something called a system call. Let's say your word processor wants to save a file. It can't just talk to the hard drive directly. No way. Instead, it makes a formal request, a system call, to the kernel. The CPU then flips a switch, entering a special, privileged kernel mode. The kernel does the heavy lifting, saves the file, and then flips the switch back to user mode to tell the app, okay, we're all good. This happens millions of times a day without you ever seeing it. And this whole dance brings us to one of the most fundamental ideas in all of computing, this great divide between the world of normal user apps and the protected world of the kernel. And believe me, this separation is there for a very, very good reason.
So, to enforce this separation, the computer's processor actually has a built-in rulebook. There's a set of really powerful privileged instructions that can control hardware or mess with the whole system, and those are reserved exclusively for the kernel. Everything else is a non-privileged instruction. That's the safe sandbox your everyday apps get to play in.
Now, check out this table, and I want you to pay close attention to that row, effect of crash. This is everything. In the restricted user mode, if an application messes up, it just crashes. No big deal, you restart it. But if the kernel crashes, it takes the entire system down with it. That is the infamous blue screen of death. This single design choice is what makes modern computers so incredibly stable.
So let's zoom back out for a second. We've seen the interface you use, the 5 big jobs it's always doing, the super important kernel at the center, and that protective barrier that keeps it all from falling apart. It all comes together to form the absolute foundation of everything you do.
So, if you're going to remember anything, remember this. The OS is that essential bridge connecting you to your hardware. It's juggling those 5 key areas all the time, with the kernel as its core. And that separation between user and kernel modes, that's the secret sauce for stability and security. At the end of the day, the OS provides the stage for all our favorite apps to perform on.
And it all comes down to this simple idea. All of that complexity we just talked about, the memory management, the scheduling, the system calls, it all serves one main goal: to make the ridiculously complex machine sitting in front of you convenient, efficient, and honestly, just easy to use.
But as our technology changes, its foundation has to change too. The graphical user interface, it was designed for a mouse and a keyboard. So I'll leave you with this question to chew on. As we head into a future that's dominated by AI, voice commands, and augmented